Okay, question 10. Have a read at that. And I'll pause the video. So really, I'm being told nothing in the question that isn't on the diagram except this. So the whole length here, the major arc, so the major arc is the bigger one. So I know that length is 69.4. And ACB, the reflex angle here, is equal to something I'm trying to figure out. So I'll call that X. So that's the only thing that's not really mentioned in the question that should be on our diagram. So how do we do that? Well, the minute you see arcs and sectors, you should be thinking, okay, what's my equation? And you need to know this. So pi d is the circumference of a circle. So I times that by the angle over 360, that converts the circumference of a full circle into just the bit I'm looking at. Okay, so it's like ratioing the full circle. So if someone said, well, what's half the circumference of a circle? The angle would be 180, So for this case, let's just start subbing out. We know the arc is 69.4. Pi, the diameter is twice the radius, so the radius is here. So that's 30, and I'm trying to find the angle over 360. So we're just going to rearrange to work out the angle, but what I could do, we'll rearrange actually. So let's times both sides by 360, so 360 times 69.4 is pi times 30 times the angle. And how do I get rid of times them by pi and times them by 30? Well, I'll divide 69.4, divide both sides by pi and 30 equals the angle. And if you do that in your calculator, that should pop up as 265 degrees. So you're getting a mark for this bit here. You are then getting a mark for rearranging, and your final mark for solving. So not bad, isn't it? So just even to write that out, you get 1 mark. Not bad. But yeah, to rearrange, I just did the opposite of everything. So I times both sides by 360, so that pops up, and I divided by this. Now I kind of think on it as like if you're downstairs, you're going upstairs. If you're upstairs, you're going downstairs. So whatever works for you, but you're doing the opposite to move it over. This one, you should be looking at this and thinking 3-dimensional Pythagoras. Again, nothing in this question that's not on the diagram. So let's work that out. Now this one, if we're doing 3-dimensional Pythagoras, I can make a triangle inside my box, and that triangle has got a length here I don't know, and I do know this one. So what I'm going to have to do is face and then space. So I do that Pythagoras twice. I'm going to work out this length on the face and then this length through the space of the shape. So this length here is quite simply part of this triangle. 24 and 6 with right angle in there. So if I was to do 24 squared plus 6 squared, that would give me, I'll call that length x. That would give me x squared. So if I do that on the calculator, 24 squared plus 6 squared, so that gives me 612. So that's not my answer though, I need to square root it. So the square root of 612 is 24.74, I'll call it. So I'm going to use that, so 24.74, I'm going to use that in my space calculation. So I'm going to say, put that up here, 24.74 squared plus 8 squared is equal to y squared, which is the value I'm trying to find. So that number squared plus 8 squared, which is 64. So y squared comes out as 676, and the square root of the answer comes out as 26 centimeters. Now, I did round this off here, like on my paper, but I just kept the number in my calculator, so that's why it's coming out quite perfectly. If you type that number in exactly, you probably have 25.99 or whatever. Okay. So I just kept that number in my calculator. But when you see this shape, you're thinking Pythagoras twice. Face to get this one, and then space to get that one. Okay, it's a very easy one to spot actually. So yeah, have that in your back pocket. Okay, so getting towards the end of the paper, we're nearly there. We've got question 12, and we're going all the way up to, just hit the last one, 14, right, nearly there. So question 12, have we read at that? So when it's time to simplifying, you're thinking of factorising so you can cancel out. So factorising is all about common factor first, then you've either got difference of two squares, or you're doing your trinomials. So on the top, we've got a common factor. I can take out 2 and I can take out a, which would leave me b plus 3. So that's the common factor one. On the bottom, I can do my difference of two squares. So that's b plus 3 and b take away 3. You just do the square root of the b, and then you do plus or minus square root of 9. Trinomials, don't forget, that's ones where it's add to give you the middle number and multiply to give you the end number. So that'd be x plus 5 and x plus 2. Okay. The harder trinomials with a number in front, I go through in other videos. But yeah, you're looking to factorise that, and then what can we cancel? That and that. Now, if you're not very good at factorising, do the easy one, and if you end up with something you're thinking, right, 2a or b plus 3 is going to have to appear on the bottom here, because otherwise I can't cancel anything. So if you do the easy one, it gives you a wee clue. If you see b plus 3, you're thinking, right, okay, b plus 3 is going to be down there. Ah, okay, I remember. Do you know what I mean? So have a wee think about that. You're not just going to factorise it and leave it. And that gives you that. So 3 marks, you're getting a mark for factorising, and then a mark for cancelling out as well. So yep, there. Again, fractions, people look at this and they really hate it. Just remember our rules when you see this. Tan x is equal to sine x over cos x. That's a good one. And sine squared x plus cos squared x is equal to 1. And also remember, something like cos squared x just means cos x times cos x. So if you remember those when you see these in front of yourself, you're on to a winner. Okay, so let's have a think. What does this mean? Well, I could break it apart, couldn't I? I could say that's the same as sine x divided by cos x plus 2 cos x divided by cos x, because if we've got a common denominator, I can break them apart in the same way that we have to get a common denominator in order to add them together. So I can break those two apart, and then I can say, well, sine over cos gives me tan. So that's tan x. And cos divided by cos cancels out to give me 1, so it's tan x plus 2. Now, people sometimes struggle to see these things, and I can appreciate that it doesn't instantly jump out. But if you write this down, it gives you a bit of a thing, because right away, even just seeing this and this, you might go, oh, okay. But have that in your mind, and you should just remember this as well, okay? So sometimes that's how you rewrite cos x times cos x, and things on the top cancel. So practice them, and hopefully you start to spot some patterns. Some people don't like them. If you don't like them, it's not the end of the world. But I think that's a nice little 2 marks. Again, when you think about some of the marks we had to fight for, doing all the work in, and this is more technical in nature, so you get marks a little bit easier. And I think I'll save this for the very last video.